This video is about finding a minimum sample size to estimate the population mean. So the idea is that we want to be very confident in our confidence interval. If we have a low level of confidence, then there's really no point in even creating a confidence interval because we can't trust it. So we need to have a high level of confidence. But in general, the way we get a higher level of confidence is by making the interval wider and wider. And that should make sense. Think about any guess you've ever made in life. If you increase your interval, you have a higher confidence of being right. For example, if I guess how many points a football team is going to score, and I think I'm confident they're going to be between 20 and 25 points, I'm going to be a lot more confident if I say between 5 and 50 points. As I made a wider interval there, I'm much more confident that they're going to fall within it. And so this video is about getting that higher level of confidence, but not expanding the interval, keeping the interval smaller so that we get more useful information out of it. And the way we're going to do that is by increasing our sample size. So here's the formula we're going to be using. And so you get to decide beforehand what the margin of error is going to be, which that's how wide your confidence interval is going to be. And then also you pick the level of confidence, which our critical values z sub c here. We pick our level of confidence for this formula. So pick your level of confidence, pick how wide you want it to be, plug it in here, and the formula will tell you how large a sample you need. Let me show you quick where that formula came from. It's directly related to our margin of error formula on page 300. So using that exact definition, if we multiply both sides by n, or the square root of n, and then we divide both sides by e, margin of error, and now we square both sides, we get that exact formula that I just showed. So to go through example 6, it's on page 304. The economics researcher in example 1 wants to estimate the mean number of hours worked by all grocery store employees in the county. How many employees must be included in the sample to be 95% confident that the sample mean is within 1.5 hours of the population mean? So there's two things we're deciding, and based on those decisions, it's going to determine how big our sample size has to be. So we're deciding we want 95% confidence, and we're deciding we want our margin of error to be 1.5 hours. All right, so if we have a 95% confidence level, that means our alpha is going to be 0.05 or 5%. So 95% of our samples are going to fall in between our critical values. That means there's 5% in the tails. So each tail is going to have half of that. So 5% divided by 2. So there's 2.5% in each of the tails. And we need to know that to get our critical value. Our z value associated with 2.5% in the tables is given by this formula. So if I put an equal sign in front of that, I get the critical value associated with 2.5% in each tail. Excel always gives the negative value back. We're going to use the positive in our formula. Now the population standard deviation was given. It's listed in example 2, which was on page 300. But we're still building off that example. So that's the population standard deviation we use. So to wrap it all up and calculate the sample size needed in order to meet our two criteria that we chose both of these things. We plug in our numbers into this formula. So use your parentheses. You're going to want to do parentheses again so that you can capture the multiplication on top. So 1.96 times our standard deviation, which was 7.9. So the top part's captured, divide by our margin of error. Now, Now we can close out all the parentheses because we're raising the entire thing to the second power. We're squaring it all. Type that in, and you get our sample size needs to be 106.6. Now you can't ask 106.6 people, and this is clearly bigger than 106, so we always round upward. Always go to the next number up, because 106 would be too small. You have to have at least 106.6. So 106 is too small. We need 107 in our sample size, and that's our final answer. So even if this was like 106.1, you still round up to 107. Always round upward whenever you're getting your final answer for the sample size.